Hi everyone, I am Kavita. Today we are going to see some basics of deterministic finite state automaton. Here in this lecture, first of all we have to know the types of finite automaton. The finite automaton can be classified into two types. One is deterministic finite automaton, that we call it as DFA, and non-deterministic finite automaton, that we have call it as NDFA or NFA. Okay. So, here the deterministic finite automaton DFA. DFA or a simple machine, it reads input string one symbol at a time. One symbol at a time only it can read. And then after the input has been completely read by the automaton, it decide this string can be accepted or rejected by the automaton. Okay. First of all, it takes the input and then only it completely it reads. After that, it decide rejected or accepted. Okay. As the symbols are read from the tape, the automaton can change its state to reflect how it reacts to what it has seen so far. Okay. So, this is the model of automaton. Thus, a DFA conceptually consists of three parts. A tape holds the input string. The tape is divided into a finite number of cells. Each cell holds a symbol from Q naught. Okay, starting symbol is Q naught. Okay, the tape head for a reading symbol from the tape head. Okay, first one, the input string, it contains the strings starting from Q naught. This is the tape head. Tape head can read the symbols and send to the control unit. Here next is control, finite control room, which itself consists of three things. Okay. So, finite number of states that the machine is allowed to be in. 0 or more states are designated as accept or final set. A current state initially set a start state. The state transition function for changing the current state. Process in automaton. An automaton processes a string on a tape by repeating the following action until the tape head has traversed the entire string. Actually, in the tape head contains input strings. The tape head reads the current tape cell and sends the symbol found there to the control room, and in the control room it takes the process, and after it will decide the string is accepted or rejected, and then it moves to the next state. Okay. So, this process is going on in the automaton. So, first tape head contains the input symbol. So, the input symbol can be read by the automaton and send it to the control. So, the control can process and the transition function get next state, which becomes the new current state. Okay. Once the entire string has been processed, the state in which the automaton enters is examined. If it is accepted by the state, the string accepted by the state, the input string is accepted, we said. Okay. So, and then it moves to the next state. Suppose it rejected, it should not move to the next state, it should be in the state itself. Okay. The string accepted, it moves to the next state. String not accepted, it rejects. Okay. This is the formal definition of automata. The deterministic finite automaton is defined by a quintuple, 5 tuples. Quintuple means 5 tuples: Q, sigma, delta, Q naught and F. Q is the set of states, how many number of states in that automaton, that should be in that Q. Okay. And sigma shows the input symbols, and delta is the transition function What is the transition means? A set of states takes the input symbol and moves to the state, next state. Okay, this is the transition. Okay, set of states takes the input and moves to the next state. Okay, so Q naught is the start state always in the animation. Okay, Q naught, and F is the set of final states, not the single final state, set of final states we have. Okay, here in the DFA. Okay, next, general notation of DFA. There are two preferred notations for describing automaton. One is transition diagram and another is transition table. Okay, how to draw the transition diagram? The transition diagram for a DFA contains this 5 tuples. Is a graph defined as follows. Okay, it's a graph. Okay, and the graph contains a node. Node means a circle. Okay, and an arrow mark. Okay, node contains a circle. The start state represents a circle with an arrow mark. Start state na always with a arrow mark. Start state always with a arrow mark, and the final state always with a double circle. So the graph contains diagram, transition diagram contains the start state and end state. Definitely start state have an arrow mark with the circle, and the end state have double circle. Okay, double circle the final state can have. Okay, and the transition function mentioned as an arrow mark, transition arc, arrow mark or arc. Node Q to node P, it label the with a label it can transit. Okay, node P to node Q it moves, that is called as input, and it shows the input symbol. If more than one input symbol cause the transition from state Q, top then arc from Q to P is labeled by the list of those symbols. Okay, so this Q to P input symbol A, with a input symbol A, we have written like this: Q comma A equal to P. That means the Q is the state, it reads the string A and moves to the next state P. Okay, so the next DFA for example, specify a DFA that accepts all and only the string of zeros and ones that have sequence 0 1 somewhere in the string. So we need to draw the transition diagram for the zeros and ones. Strings contains zeros and ones and that have sequence 0 1. For that we need to draw the diagram, transition diagram. So here this is the transition diagram. 0 1 is a substring. Suppose we can take substring na, its length of the substring na 0 1 1 1. Okay, so the length is 2. Okay, number of elements contained in the string is called length. Okay, here two numbers contained. Okay, so the length is 2, so n plus 1, so 3 states we need. Okay, to draw the diagram. Okay, 3 states: Q0, Q1, Q2. Okay, here Q0 is the start state with the arrow mark, and Q1 I mentioned as a finite state, double circle. Okay, final state na double circle, initial state with the arrow mark. Okay, so 0 and 1 should be accepted by the sequence of zeros and 1 should be accepted by the diagram. Okay, so here 0 1, first of all we need 0 and 1, so connect the Q0 to Q2 as 0 and Q2 to Q1 as 1. So 0 1 can be accepted by this automaton, and then some self loop we need to draw for the sequence of zeros and ones. Okay, so for that we draw the self loop: zeros and ones, zeros and ones, zeros and ones. Okay, so this gives the sequence of zeros and ones accepted by the automaton. Okay, this is the transition diagram. How can you draw the transition table for this diagram? You just the transition table is a conventional tabular representation. It's a tabular representation only for the function of delta. Okay, that it takes two arguments and return a value. Okay, here the rows of the table corresponding to the states, rows and all in the table corresponds to the states. Okay, here in the states, the arrow mark mentioned the start state and star mentioned the final state. Okay, the states and all star and arrow mark mentioned the start state and final state. Okay, so the states and the column correspond to the input, inputs. The entry for the row corresponding to state Q and the column corresponding to a input A is state Q comma A. Okay, the start state is marked with an arrow and accept state all are marked with a star. That means the final state marked with a star. Okay, this is the transition table for the given diagram of zeros and ones. Okay, here Q from Q naught, what are the moves zeros and ones? Okay, so what is the move when Q naught reads 0, where it moves? It moves to Q2. That we have to mention in the table. Q naught reads 0, it moves to Q2. Q naught reads 1, it's in Q naught itself because it's a self loop. So Q1 reads 0, it moves to Q1 itself since it's a self loop. Okay, the Q1 is with self loop 0. Okay, so the Q1 reads 1, again it's in Q1 itself since the 0 and 1 is in the self loop in the Q1. Okay, so next Q2 reads 0, it's in Q2 itself since it's a self loop. Q2 reads 1, it moves to Q1. This is the transition table we have to write. From the transition diagram we can easily write it. Okay, on seeing the transition diagram we easily draw the transition table. Okay, extending and transition function to string. If delta is a transition function, then the extended transition function constructed from delta is a function that takes a state Q and a state W and returns a state P, the state that the automaton reaches when starting in state Q and processing the sequence of input W. Okay, so the DFA contains 5 tuples. Q is the number of set of states, sigma input strings, and delta the transition function, Q naught the initial state, F the set of final state. The function delta is extended as delta Q. It takes the inputs and moves to the next state. Okay, so and is defined recursively as for any state Q of Q, delta Q reads any string and moves to the next state Q. Okay, this means that DFA stays in the same state Q when it reads an empty string at Q. Okay, so for any state Q of Q, any string x belongs to sigma star with A as the last symbol x and A belongs to sigma. So therefore the transition function delta Q takes the symbol XA, means the delta first of all reads the symbol input X, okay, and then it moves to the next symbol A. Okay, so language accepted by the DFA. What is the language accepted by the DFA? The language accepted by the DFA with 5 tuples is the set of all strings on sigma. Sigma means the input symbols, right, accepted by M. So L of M equal to W belongs to sigma star sigma star clean star, and the delta transits q naught and reads the word w belongs to the finite state. Okay. The language of a DFA is a set of all strings w with w that takes DFA starting from start state to one of the accepting state. So, simply we say when the string start from the start state and end from the final state, we say the language is accepted. Okay. The string start from the start state and end with the final state, the string said to be an accepted string. Okay. So, accepted string language, that is called as language accepted by the DFA. Okay. So, thank you. See you again in the next video, and then bye from Kavita.